Welcome to the DIY Honda Garage channel. The DTC P0522 pertains to the rocker arm oil pressure sensor, also known as the EOP sensor, in the Honda Civic models from 2006 to 2011. This error code indicates a low voltage condition within the EOP sensor circuit. The EOP sensor plays a crucial role in monitoring oil pressure in the engine, ensuring optimal performance by regulating oil flow to the rocker arms. A malfunctioning sensor can lead to insufficient lubrication, which may result in engine damage. You'll find this sensor located near the valve cover on the engine block, often surrounded by wiring harnesses. Understanding this code and its implications is vital for maintaining engine health and performance in your Civic. The error code P0522 is primarily linked to the rocker arm oil pressure sensor, which monitors the oil pressure necessary for the engine's optimal function. This sensor is essential for ensuring adequate lubrication of the rocker arms, thus playing a vital role in engine performance. Located near the valve cover on the engine block, the EOP sensor's functionality is pivotal. A failure can lead to serious engine damage. Working in conjunction with the Engine Control Module, ECM, it communicates crucial data regarding oil pressure that helps manage oil flow. If the circuit is sending low voltage, it's a signal to investigate potential issues within the sensor or its connections. Therefore, understanding this error is crucial for vehicle reliability and longevity. The potential causes for DTC P0522 primarily include poor connections and loose terminals at the EOP sensor or the Engine Control Module, ECM. Poor connections can disrupt the electrical flow required for the sensor to operate correctly, leading to a low voltage reading. Loose terminals may create intermittent contact, causing the system to fail temporarily. Additionally, the EOP sensor itself could be faulty, meaning it is unable to accurately measure oil pressure. Mechanical issues such as low oil level or debris blocking the sensor could also contribute to this error. It's essential to evaluate these possibilities methodically to identify the root cause accurately. Common symptoms associated with DTC P0522 include the check engine light illuminating on the dashboard, indicating a malfunction within the system. Driver may also notice poor engine performance, such as reduced acceleration or hesitation. Unusual engine noises could also arise due to insufficient lubrication resulting from low oil pressure. These symptoms may become more prominent during demanding driving conditions, where oil flow is essential for engine function. Furthermore, decreased engine efficiency can lead to increased fuel consumption, impacting overall vehicle economy. Recognizing these symptoms early may prevent further engine damage and costly repairs. The first step in troubleshooting DTC P0522 begins with turning the ignition switch to the on position, labeled as 2. This action is crucial because it powers up the vehicle's electronic systems, allowing for diagnostics via the Honda Diagnostics System, HDS. Next, you should check the oil pressure sensor's data list using the HDS. The objective here is to monitor the voltage reading from the EOP sensor. If the reading is approximately 0.18 volts or less, you are directed to proceed to the next troubleshooting step. If the voltage is higher than this threshold, it indicates an intermittent failure that necessitates checking for poor connections or loose terminals at the EOP sensor and the ECM. This initial step is imperative for ascertaining whether the sensor is sending accurate data to the vehicle's computer. Following the findings from Step 1, the next action is to turn the ignition switch to the lock position, designated as 0. This step is essential for ensuring safety while you perform further diagnostic operations. After the ignition is locked, you must disconnect the 3P connector from the rocker arm oil pressure sensor, also known as the EOP sensor. This step isolates the sensor, allowing for a more accurate assessment of the sensor's functionality without influencing electrical readings from the ECM. By detaching the sensor connector, you can evaluate whether the sensor itself is malfunctioning or if other components in the circuit are the source of the issue. This isolation is an integral part of the troubleshooting procedure, as it allows for focused diagnostics. For the third step, once again, turn the ignition switch to the on position, marked as 2. This action will energize the electronic systems within the vehicle, allowing you to take another reading from the rocker arm oil pressure sensor. You need to check the HDS data list for the sensor's voltage. The critical point here is to determine if the voltage falls at or below the 0.18 volts threshold. If it does, you should proceed to step 8. If the voltage exceeds this limit, it indicates a malfunction within the circuit that could involve faulty wiring or connections. Both the immediate and historical data readings are vital for diagnosing the issue accurately and ensuring that the repair is effective. In this step, you will measure the voltage between the terminals of the rocker arm oil pressure sensor connector, specifically terminals number 1 and number 3. You will utilize a multimeter for this measurement, which is vital for electrical diagnostics. Identifying the voltage at this point can provide essential clues about the integrity of the sensor and its connections. The critical condition to check is whether the voltage reads about 5 volts, which is the expected operational voltage for the system. If the voltage is indeed around 5 volts, it indicates that the EOP sensor is likely functioning and the problem lies elsewhere down the line. Conversely, if the reading is lower, it points toward an issue within the electrical circuit, requiring a deeper investigation into potential disruptions. The fifth troubleshooting step begins with turning the ignition switch to the lock position, marked as 0. This precaution ensures that you can safely manipulate the vehicle's wiring and connectors. After locking the ignition, you will need to jump the SCS single circuit selector line using the Honda Diagnostic System, HDS. The SCS line is crucial for performing specific tests and ensuring the correct functionality of the ECU, engine control unit. By jumping this line, you can set up the diagnostic system to focus on resolving the fault associated with the DTC. This step is crucial for confirming the operational status of the ECM and helps isolate faults without interference from external systems. For this step, you will disconnect the ECM-PCM connector, specifically connector C, which consists of 44 pins. Disconnecting the ECM allows you to isolate the engine control module from the rest of the circuit, providing a clearer picture of the various components and their condition. After disconnecting, you'll need to check for continuity between the rocker arm, oil pressure sensor, 3P connector, terminal number 2, and body ground. Continuity testing is essential. It verifies that an electrical path exists and that there are no breaks in the circuit. If continuity is confirmed, the grounding system is functional, suggesting that the EOP sensor or wiring may be at fault. In contrast, a lack of continuity would indicate a grounding issue that needs to be addressed for proper operation. After all necessary repairs have been performed, it is crucial to conduct a final verification of your work. Begin by rechecking the oil pressure sensor data using the HDS to confirm that it is operating within the expected parameters. You should look for a normal voltage reading, indicating proper sensor functionality. Additionally, ensure that no further diagnostic trouble codes, DTCs, are present in the system. This step not only confirms the effectiveness of your repairs, but also safeguards against future issues. A clean diagnostic report provides peace of mind and reassures that the vehicle is operating safely. If there are any codes remaining, they will require further inspection to prevent recurring problems. Preventive maintenance is essential to ensure the longevity and reliability of your Honda Civic. Regular oil changes are critical as they maintain proper lubrication in the engine and allow the rocker arm oil pressure sensor to function optimally. Additionally, periodic checks of the sensor connections can preemptively identify any loose or corroded wires that may lead to DTCs like P0522. Making it a habit to inspect these components can save you from costly repairs in the long run. Always refer to your owner's manual for recommended maintenance intervals. By following these guidelines, you can greatly enhance the performance and lifespan of your vehicle. In conclusion, understanding DTC P0522 involves recognizing the vital role that the rocker arm oil pressure sensor plays in engine performance. Proper troubleshooting requires systematic methods, including voltage checks and continuity testing, to accurately pinpoint the issue. Awareness of potential causes can streamline your diagnostic process, allowing for quicker and more effective repairs. Regular preventive maintenance and monitoring of your vehicle's sensor and electrical connections can help minimize the likelihood of encountering similar problems in the future. By being diligent and informed, you can maintain your Honda Civic efficiently, ensuring its reliability and performance for years to come. Please like and subscribe to the channel. See you next time.